Hi there. In a previous video I made a milling spindle out of an old 540 motor and a battery pack. Now this worked out surprisingly well, but the battery pack only gave me about 10 minutes machining time. Maybe with a smaller machine that would have been fine, but this will go up to A3, so I needed something a bit bigger. So I found on eBay a palm held router. Now this is brilliant, works absolutely fantastic, and then attach this to the machine. The only problem is this weighs about 1.5 kilos. And what happened was the bearing for the nut for the lead screw stripped. It was too heavy for it. So what I intend to do is build a complete new Z-Axis. I've spent some time designing it on FreeCAD, which was a useful free design program that I found, and I've got some parts mainly on eBay, mostly from China, to make the new Z-Axis out of. So we've got some supports and two new linear rails. Now I had a lot of trouble cutting these because the case hardened, so I did end up doing them at work in the end. But I found that some places would actually cut them to the length you wanted, so that would sort that out for you. And then for a lead screw I'm using an M8 thread, mainly because the bearings that I bought, I've got an 8mm hole in it, so I've got to make a nut to that at some point. The original design only had 2 bearings, and that gave it a little bit of flex. So I've got 2 more linear bearings. These are 12mm shafts and the appropriate 12mm bearings to go with. I did actually buy quite a good lead screw, which is the one that goes with the bearings, and that came with the proper nut and I forgot what it's called.
Don't ask me.
Coupling. But what I discovered was that one turn on here was 10mm, and I thought that might be too much for this, as I needed more torque than that. The 8mm threaded bar has a pitch of 1.25mm, so for every one turn it's 1.25, whereas this is 10mm. Putting all this together should be a relatively straightforward job, and I'm hoping it's just going to be bolting all bits together. The only thing I've really got to do is cut this and also drill all the holes on it. What my idea was, I'm going to print off from the CAD the back plate and the front plate, stick them onto here, and then I can drill through from the holes on the drawing. The other idea that I had that I might have a go at is, as I've got a semi-working machine, I might try drilling them out using the CNC. A toolpath was created from a step file using Delcam's power mill. The centres of the holes were marked out using a spot drill. You could also use a rule and a centre punch instead. All of the holes were first drilled out with a 4mm twist drill. Any clearance holes were drilled through with a 6mm drill. Then chamfer all of the holes with a 12mm twist drill. I got a cheap tap set and wrench from a local DIY shop. Make sure you use a lubricant when tapping in aluminium, as it will pick up and tear. I just use some squirty oil in a spray can. All tapped holes are M5. centre punch and then chain drill for the stepper motor cutout. Cut down both sides with a hacksaw to remove the unwanted section. Use a file to neaten up the rough edge from the chain drilling. I made a nut for the lead screw next, out of 6mm thick brass bar, which was first cut to length. I then marked out the hole positions with a centre punch. Centre drilled and then went all the way through with a 4mm twist drill, and finally a 6.5mm drill for the threaded hole. Make sure you unplug the drill before inserting an 8mm tap into the chuck. This will keep it square when going into the drilled hole. Use oil and keep pressure on the drill press whilst turning the tap to start threading the hole. When it started getting too stiff, I had to use a centre punch to get more leverage. And the last two holes were tapped by hand. Next, I made the stepper motor and brass lead nut holding brackets. I cut two pieces of 50mm aluminium angle. Marked out, drilled and cut out the bracket for the nut. and repeated the process for the stepper motor support bracket. After all the parts have been made, I'll put it all together as a complete independent unit. I had to take the old Z-axis apart before I could build the new axis. I had to partially disassemble the new Z-axis so I could fit it to the current Y-axis. I needed to change the number of steps per millimetre in the Gerbil settings on the Arduino. For the M6 bar it was 200, but for the new M8 threaded bar it is now 160. I also reduced the Z-axis maximum speed. I tested the new axis doing some 3-axis V carving, making some pet nameplates, which will be in another video. So that's the new Z-axis, finished and working. It turned out it was quite cheap and easy to make and has worked far better than I expected. The next upgrade I'm planning on doing to this machine is to add another stepper motor down this side because it still has a little bit of play in it, and hopefully that will sort that out. If you made it this far, well done. Please like and subscribe. I'll see you next time.